Slope. Okay, this is a big one. Slope. When you think of slope, I usually think of like a ski slope or anything that's on an angle, but slope for mathematical purposes is the rate at which a line increases as it rises versus its run, or decreases as it rises versus run. That's a real technical term, but let's just get an idea of what we're talking about here. I've got a four-quadrant coordinate plane here. I'm just going to put some lines on it, kind of randomly. Let's get a slightly better marker there. There's one. There's another one. Let's get a steep one. There's another one. Let's do one more. Put it like this. Like that. So there's four different lines. Each of those lines has its own slope. Some of them are steeper than others. Some of them are increasing. Some of them are decreasing. As we look at these, we're always going to read this kind of left to right, just like we read. So when we look at these lines, if it's increasing going left to right, we would say that's positive. So this slope right here is positive. This slope right here is decreasing, so we'd say that that slope is negative. Now, for our purposes, we're going to use this in equations form. So what we have for slope is the letter m. And the letter m is going to be our variable that represents slope. Now remember, slope is a comparison of how that line rises versus how it runs. And what we're talking about then is it's a comparison of x to y, or more specifically, y to x. So just so we remember, this is the y-axis here. This is the x-axis. And what we find when we find the change of y over the change of x is slope. So our change of y, how that line rises or falls, and the change of x, how that line moves to the left or to the right, and that gives us slope. Here we have a graph with a line already drawn on it, and we've got two ordered pairs. So we're going to use those 2 points to figure out what the slope of that line is. Now there's a thing called a slope formula. I'm going to show you the slope formula. So when we're finding slope, what we're finding is the change of y over the change of x. So how does y change versus how does x change? And that triangle I'm drawing means delta. It's the Greek symbol for delta. And in math and geometric circles, what we do is we say that as change of. Right? It's a lot easier than writing C-H-A-N-G-E-O-F with a space in there, the appropriate space, not a space anywhere. But this is the change of y over the change of x, and how we're going to figure that when we're given 2 points is we're just going to subtract one of those points from the other. So what that means is we're going to subtract, let's say, the second point from the first point, the y's, and we'll subtract the x the same way. Now, the way this is set up, if I write this on here, is that this point, this is our y, nope, this is our x sub 1, comma, and our y sub 1. Now those sub numbers are not exponents, those are just delineators. Those are just telling us which point this is. So for us, we're going to call this point 1. We don't have to label it as such because we have labeled it by saying x sub 1 and y sub 1. And this one's going to be, let me do this one in green so we see the difference here. This one's going to be x sub, you got it, 2 and y sub 2 because that is point 2. Now those sub numbers, those don't have any value. They're just placekeepers to remind us that this is point 1 and this is point 2. Now when we apply this to our slope formula, what we're going to do is we're just going to take the pieces of these and put them into the formula and then solve. So corresponding thing, we're going to do y2 minus y sub 1. So y2 right there is 6, and that's going to be 6 minus 4. There's my 4. And then I've got my fraction bar, because it's a ratio. Slope is a ratio of the comparison of delta y and delta x. And then I've got x sub 2, which I'm writing in green here, which is 3, minus, and then in purple, x sub 1, which is 2. No, that's not purple. That's purple. Not, what, like lavender? What color is this? 2? No? Let's try this one. There it is. Okay, so just to be clear here, we've got our y's over our x's, change of y, change of x. Y is always going to be our numerator. So I've got my second point, 6, minus my first point, y. That's y's. Or my first point, 4. And then I just do the math here. And the math tells me that let's try a black. 6 minus 4 is 2. 3 minus 2 is 1. Therefore, the slope of my line is 2 over 1. And that's the change of y over the change of x. Change of y, change of x. Now here's the twist with this. When you look at this, this is saying that it will rise 2 and run 1. Now, sign matters here. So plus 2, positive 2 means it's going up 2. Every time we go plus 1, right 1. So go right 1, up 2, there's a point. Right 1, up 2, there's a point. Up 2, right 1, there's a point. Up 2, right 1, there's a point. Up 2, right 1, there's a point. Now that rate of change is constant and it will go on forever. That's what creates the line. That's what makes our linear equation. Now we have a table, and for order for us to find the slope of this table, what we have to know is that given this is a line. So this represents a linear equation, but just in table form. Let's go back to slope. All right, so slope is the change of y over the change of x. And we use slope formula to say y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And it does not matter which points we pick. We can pick them next to each other. We can pick them far apart. But because this is linear, it will work. So just so that we're clear about what we've got here, let's call this our point 1. So we've got 1, 12. Kind of a reminder here that that's x and y. And then let's make this one 0.2, and we'll say this is 7, 3. And now we're going to fill in our pieces. Okay? So we're going to substitute in for these things. If this is our second point, we're going to say, here's my y. Whoa, caught it. We're going to say 3 minus my first point, 12. Don't let that throw you off. That's okay. And then we got to start with our second point again. 7 minus 1. Okay, let me move this out of the way for us. And now we just do the math. 3 minus 12. Okay, so 3 take away 12. Or we're combining a positive 3 and a negative 12. That gives us negative 9. And then 7 minus 1 is 6. We've got a ratio, but that ratio is not simplified, so let's simplify that ratio. We can divide both of these by 3, and we can get negative 3 over 2. And that's a great slope right there. M equals negative 3 over 2. Now, what do we know about that? What does that negative 3 over 2 actually mean? Does that mean the line is increasing or decreasing? It's decreasing, right? So we have a negative slope. That means it's decreasing, which means that line is going, if we start from the point here, it's going down 3 steps and then right 2 steps, and there's my next point. About something like that. Now that negative could be on either side, but I always prefer to have my x be positive. Because you could also write this as 3 over negative 2, which is the exact same ratio or fraction. And 3 over negative 2 would mean that if I was at a point here, I'm going to go up 3, positive rise, 1, 2, 3, and then I'm going to go left 2, 1, 2, put me there. It's the same line. We're just counting it in a different direction. Ooh, fancy. How can we find slope from 2 points? Well, first of all, do we have a straight line? Of course we do. If we only have 2 points, wherever those 2 points are, those are going to form a straight line. So if it wasn't there, let's say it was here, that's a straight line. Let's say it was here, that's a straight line. So given 2 points, we can find the slope of the line that would connect those 2 points. Let's not forget what our slope formula is. M equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Just for my purposes, I'm going to call this one point 1, if that helps you, and this one point 2. Just to remind you, that's okay. If you'd like to go and label them, that's fine too. You could say that this is x sub 1, y sub 2, x sub 2, y sub 2, no, y sub 1, comma. And now we're just filling in the formula and solving for the slope. So I've got m is equal to y sub 2, which is 4, minus, because we want the change, negative 2. Oh, great example here. That negative is not that minus sign, okay? That's there no matter what the term is. So that's got to be subtract negative 2, or we've got that double negative situation. And then my x sub 2 is 5. And then we want the change of to negative 3. Okay, so going back to our integer operations and working with that, let's rewrite this without those pieces being double negatives. So if I'm saying the opposite of the opposite, so if I have 2 and the opposite of 2 is negative 2, the opposite of negative 2 then is positive 2, which gives me 4 plus 2, and then 5 plus 3, and that is 4 plus 2 is 6, 5 plus 3 is 8, and now we have a slope of 6/8. No, we don't. Don't forget, when we're working with fractions like this, it's vital that we simplify those fractions. I'm just going to bring this over here. We can divide both of these by 2. And now we have a slope that is 3/4. So I can ask you informally, is that line between these 2 points, is it increasing or decreasing? You should know. You should know how many steps it's going up and how many steps it's going to the right, because we know that this is the change of y and this is the change of x. There's a lot we can tell from slope. Vocabulary and formulas. Let's look at what we've got here. Let me write our vocab, so just to make sure that we're all on the same page here. First of all, we have slope. That's a big one, and that is a ratio of rise to run for a line. We also have, let's get this in there, that is delta, which means change of. We also have a slope formula. Slope formula, which is m is equal to y sub 2 minus y sub 1, which is the change of y, over x sub 2 minus x sub 1, which is the change of fancy x. All right, that's a good start. Good luck.